Okay, so this is something I've been working on for some time, and it's something that I've mentioned to a few people, and I haven't been able to really explain what it is and what it does and how it does that verbally without some sort of moving picture format. So I thought I'd do a quick video on it and just demonstrate the various things that it does. So what is this crazy device that I've invented? Well, it's an instrument that measures the difference in pressure between 2 points. There's 2 ports on the back where you can insert a couple of tubes, and you can do what you want with those 2 tubes. One of them you can put into a low pressure or a high pressure environment, and the other tube you use it as a comparison. So you can keep this one in open air and it will compare atmospheric pressure to wherever you put the other one. Or you could have 2 totally enclosed areas that are at varying pressures and compare the difference between the 2 of them. And one of the things that it's sort of aimed at is different enclosures within controlled atmospheres. So asbestos disposal, nuclear power stations, that sort of thing, where the disposing of equipment where you need to control the direction of airflow and a vacuum or lack thereof within an enclosure will imply airflow in a certain direction. So what is it that this thing does? Well, it measures the difference in pressure between 2 points. It'll display that pressure difference as either a digital readout with a needle on a gauge readout, or a graph over time, so that you can see a trend over time, whether or not the air pressure is gradually going up or whether or not it's gradually going down. It alarms when either an upper or a lower pressure limit is breached, and those pressure limits are settable through the user interface. It logs the pressure difference and stores the data inside the machine as a CSV file, which is comma separated value files. CSV files are, you can just open them with Notepad or similar programs on a Windows PC, and you can look at the data quite easily from there, but it's an interesting and easy to work with format because you can easily import it into things like Excel, other database and spreadsheet programs. Comma separated values work well with Office applications, so you're able to convert that information into graphs on your PC for presentation to other people or record keeping, whatever it is that you need to do with it. And lastly, it will switch on an auxiliary air mover. So if a pressure limit is breached, then one of the things that this device can do is switch on an auxiliary air movement system, so another extractor fan for instance, and that will help to overcome blocked filters or a motor failure on your primary air mover, and it forms a sort of closed loop control system where the system looks after itself. On later implications, one of the things that I'd like to do is speed control, so that you could set a target air pressure and this device would control the speed of your air movement system, so that it neither drew too little nor too much air and thus exposed the enclosure to too little or too much vacuum, because those 2 conditions in their extreme can be dangerous. So what I'll do is I'll take you up a little bit closer and I'll show you the user interface, and we'll do a bit of air measurement. Let's go for it. Okay, so a run through the menu system. Here we've got the main menu, of which there are 2 layers. I'll go on to the next layer by hitting next, and what happens is we get the next layer of menu system. So here we've got admin. Now this would be password protected, or well, pin protected. If I hit enter, then what will happen is nothing, because that's the incorrect code. So we put the correct code in, and in this case I've used 1066, hit enter, and it will take us to the admin menu, where we can do things like set the actual pin to get into the admin menu, and I'm going to set it to all the zeros. Hit enter, and the new pin is stored. Okay, so if I were to go back to the original menu now, and we go to it always defaults back to the first layer, so we need to go to the next layer, hit admin, and if I now enter 1066, which is what it was before, and hit enter, nothing happens. It resets back to 0. So the password is now all the zeros, which makes it nice and easy to just hit enter, and we're into the admin menu. Okay, we've got temperature control. Temperature control, at the minute I've set it so that the target is 0. It isn't capable of cooling, only heating. The idea being that you can heat it above the ambient temperature. So at the moment it's 22 degrees centigrade inside the case. So what this is for is to prevent fluctuations in temperature affecting the pressure sensor. It is slightly temperature sensitive. Okay, we can go back. I'm not going to adjust the target. I don't want it to heat at the moment. I/O test. I/O test defaults to full brightness, which just gives you the ability to see what it is that you're doing, and it just lets you know what's going on with the various analog inputs, the various digital outputs. You can adjust them. That's for the heating. It'll automatically switch itself off because it's doing that through logic. These are the two digital inputs, and if I were to plug in the IEC plug into the back of the device, then what you'll see is it'll start to charge, and you'll see the charging readout go red. Okay, so it's just a screen to allow you to do troubleshooting, basically. Nothing more than that. This isn't something that you'd normally see as a client, I guess. It's more an admin menu, as the name suggests. So we'll go back to the original admin menu, and we've got brightness control. And at the moment the maximum level is set to 100, and you can see it's, you know, just blowing the camera out. So we'll drop that down to 2% and back out of there. It doesn't affect the some sections of the admin menu for usability purposes. But that's it for the admin menu. Okay, back to the first layer of the menu screen, and we go on to next for the second layer of the menu system. We've got device info. There's a QR code which would take you, my idea is that it will take you to a website where we could have things like the calibration certificate stored and various other bits and bobs, serial number and all that sort of good stuff stored down the left hand side. Okay, we hit next again to the second layer of the menu system. Again, it always defaults back to the first layer. Airflow calculator. The idea of this is for extraction scenarios where you need to achieve a certain amount of airflow to give you a certain amount of air changes per hour. So, oh dear me, I'll just knock that to 0 on everything. Bear with me here. The camera can see the screen really well, but I actually can't with my eyes because it's so dark. Okay, so at the moment it's in meters. You can swap over to imperial if you prefer to work in imperial, and everything would then be in feet and cubic feet per minute, whereas if you swap onto metric, then all of the measurements are in meters, and the airflow reading would be in cubic meters per hour. Okay, so you set the length of the room, let's say it's, I don't know, 12 meters long. we'll set the width of the room, say it's 2 meters wide, and we'll set the height of the room, and we'll say that that's 2 meters high. That automatically gives us the total volume of the room. You then select air changes per hour, and you tell it how many you want. Say you want 10 air changes an hour, then you would require 480 cubic meters per hour to give you your 10 air changes an hour. This is something that's used in asbestos disposal mostly, but it could have other uses. Okay, so that's it for the second layer of the menu system. This is now the first layer of the menu system. We've got pressure limits here. Pressure limits allows you to set a upper and lower limit. If the current pressure were to rise above or drop below the upper or lower limit, then it would alarm. It will take you to a separate screen telling you what's going on, and it will activate a couple of relays which are capable of switching on auxiliary air movers and external alarm units. If you switch the alarm on, then you get a little repeated icon at the top there telling you that that is happening, so that when you navigate to other screens, just bear with me here, we'll set that to there, and I'll set that to something unachievable like 200. Okay, that'll do me for now. So if I go onto another screen here, back to the original menu screen, oh yep, there you go, and it has alarmed. Now if you listen for the relay clicking when I acknowledge, okay, what that would do is cancel the external alarm, but you can see here there's another little icon come up to say that you've breached the lower limit. Even just momentarily it will trip. The sensitivity of that could be increased or decreased, I guess. To vanish that, you need to return the pressure to normal. At the moment there's still a relay held in to keep your air mover running. Okay, so if we switch the alarm system off, it will cancel both. Okay, back to the original home screen, and click, there you go, the air mover's off. Okay, so pressure monitor. I won't go into pressure graph because we can go into pressure graph from the pressure monitor. You can toggle between the two. There's varying scales here. The two fixed scales are -100 to +100 pascals, and then we've got a separate one which is 0 to 100 pascals, and we've got another one here which is automatic. Automatic gives you a total scale of 40 pascals at any one time, and if you breach the outer limit in either direction, then it will automatically scale slightly left and put the needle basically in the middle of the screen. Okay, so just to give you a little bit more resolution. So this is what the 0 to 100 pascal screen looks like, and if we hit this button here, then it takes us to the graph readout. Obviously, because we haven't been measuring any pressure, there's no data to display. So what I'm going to do is I'll do a camera cutscene at this point, and I'll feed it some pressure, and we'll see what happens. So I'll just take us back to the original screen here, and I'll see you very soon. Right, so I've got my pressure source plugged in, and it's running at absolute flat bus minimum. What you might notice is that this will flicker around somewhat because this is a live readout, whereas this is damped down somewhat. It is an average over the last 4 seconds, so it's a little bit easier to read. But if I start to turn the pressure up here, it should be about 10 pascals or thereabouts. Okay, and you may hear the fan going a little bit in the background. Okay, so what I'm going to do is I'm going to run it for some time at about 50 pascals, and I'll do a cutscene here, and I'll bring you back in a short time. What I'll do is, off camera, I'll turn it up to perhaps 70 pascals, and then we'll see what happens on the graph readout. Right, so some time has passed and I've been recording at 70 pascals for some time. As I say, we started out at 50 odd and I've wicked it up to 70 now, so we should be able to go across to the graph screen and it will show us that recorded data. Okay, so just here you can see, you should be able to see the 50 pascal mark, and then there's a slight rise, and then you can see the 70 pascal trace. Okay, what we'll do now is pull the information from the device. So we've got an app here, it shows the connected device, retrieve device logged data, and we'll just remove the 24-hour one. Okay, and that's that for the app, and if we have a look in here in logs, then we'll see that file just there. If we have a look at that in Notepad, then we'll see each individual recording has a serial next to it, and then the year, the month and the day, followed by the time, hours and minutes, and then seconds, and the last reading is the pressure. In this format it's quite hard to read and you can't do a lot with it. However, if we go into LibreOffice or your Office application of choice, then what we can do is open it up using that. Okay, there we go, and it opens up in this format. So now one of the things that we can do is, we don't want to select the serial, we want to select just the date and time followed by the pressure. Okay, and really quickly you can start to make interesting graphs which show what was happening with the pressure and the exact date and time that happened, and obviously what the pressure was. So here you can see this is where we were just at the beginning. I was ramping up and then it sat at 50 pascals or thereabouts and I turned it up to about 70. So you can see from this how useful this could be to process that data and do other things with it. And you can print this out as part of reports and make various documents and records and logs from it. And that is about it. Okay, so summing up, it's taken a while to get this device to this stage of construction. I've had to do all the concept design myself, the circuit design, design the user interface, program everything up. It's been a tough journey so far. I've been at this for a long time now. This is obviously just a prototype. As I said earlier, it's the outer case is irrelevant because the machinery of it, the circuit board, the screen mechanism, the backup battery, it can all be mounted into other enclosure systems. It depends entirely on the customer as to what they'd need. Some people may want it mounting permanently on a wall on an enclosure, on a permanent installation. It could be that they'd prefer it to be in something more like a pelly case arrangement, so that it's the kind of thing where they can get to site, they can open the lid, open it up and just use it, but then when they're done they close the lid of the pelly case and it's the sort of thing where you can just pick it up and take it away and chuck it in the back of a van and it'll be fine. So, you know, I prefer this type of instrument where it's desktop use. It's, you know, more like a bench top instrument in this disguise here. But this is obviously just a prototype, just to demo the capabilities of the concept, and you know, the outer case is irrelevant. Okay, so I think I've covered everything that I needed to cover. If you need any clarification on anything, you know, let me know. The only thing I've got to do now is just sort of contact a few people that I made contact with in the early days, and let them know that this is you know, now ready for sort of beta testing, if you like, and they can have a look at this device and put it to use however they see fit, and hopefully they'll break it a few times so that I can work on any weak points that show up as a result. And you know, once it's proved and it's ready to go, I can start looking at mass manufacture. Okay, thanks for watching, and I'll see you soon.